In this video, I will talk about graphs of frequency distributions. We will discuss how to construct frequency histograms, frequency polygons, relative frequency histograms, and ogives. So first, let's talk about a frequency histogram. It's a bar graph that represents the frequency distribution. The horizontal scale is quantitative and measures the data values. The vertical scale measures the frequencies of the classes. The bars must touch. Consecutive bars must touch. So the general shape, or basically you've probably seen histograms before, looks something like this. They got the data values along the x-axis and the frequencies along the y-axis. Because consecutive bars of a histogram must touch, bars must begin and end at class boundaries instead of class limits. The numbers that separate classes without forming gaps between them. So let's look at this example. We're going to draw a frequency histogram from this frequency distribution. We talked about this frequency distribution in my last video. So what we're going to do is we're going to determine the class boundaries. So we know the distance from the upper limit of the first class, which is 190, and from the upper limit the distance from the upper limit of the first class to the lower limit of the second class is 1. So the upper limit was 190, the lower class limit for the next class was 191. So that's a difference of 1. So what we're going to do is we're going to cut that 1 in half, which is 0.5. Half the distance is 0.5. So your first class boundary will be 154.5. So basically you go one back or half back, and then your first class upper boundary will be 190.5. So you go half up. Okay, so you go half back from the lower limit, half up for the upper limit. So these are your class boundaries, as you can see in the second column. All we did was go half back, half up. So I got it for each class, and then you can draw your frequency histogram. So if we look at the first class, let's look at the second graph. These are the same types of graphs, except the vertical axis is, horizontal axis is different. So if we look at the second one, we're looking at the class boundaries. The first class boundary was 154.5 to 190.5, and it has a frequency of 3. So when we go from 154.5 to 190.5, right here, we draw our bar up to 3. So right here it goes up to 3. For the second class, we had a frequency of 2. So we'll draw the bar up to 2. Now there are two ways you can make a histogram. You can either do it with the class boundaries, or you can do it with the midpoints. We know the midpoint of the first class was 172.5. The middle of this first class is 172.5. I don't have it on this slide, but that's what we did in our last video. That's the middle of this class. So we can draw the bar there. 172.5, it has a frequency of 3. The next one was 208.5, it has a frequency of 2. So as you can see, they have the same shape, different horizontal axis. You want to put a broken axis here to indicate this is where your graph starts. You never started at 0. Okay. So as you can see, this is a visual. Before we just had tables or charts and we just looked at the numbers, but here you have a graph, and from this graph you can see that 2/3 of the adults are paying more than $262.50 for out-of-pocket prescription medicine. Okay. All right. So now let's look at a frequency polygon, and it's a line graph that emphasizes the continuous change in frequencies. So we're going to do a frequency polygon based off this data here. And to construct it, we're going to use the same horizontal and vertical scales that we used in the histogram labeled with the class midpoints. So our vertical axis will look like this. It will have these numbers. Those are the class midpoints. And when you draw a frequency polygon, it should start on the x-axis and it should end on the x-axis. So it should end on the horizontal axis. Start and end on that axis. So what we're going to do is, since our first midpoint was 172.5, we need to go back. And if you recall, our class width for this particular problem was 36. So what we're going to do is we're going to go back 36, and that gives me 136.5. This was our midpoint for the last interval that we had, but we need to go up 36. So when we go up 36, this gives me 42.4. Sorry, 424.5. So when we draw our graph, we're going to draw our numbers at the midpoint. So for the first class, for this first class, we have a frequency of 3. So at our midpoint, 172.5, we're going to go up to 3. The second class had a midpoint of 208.5, had a frequency of 2. So then we draw our graph down to 2. Okay? But you have to put a line going back to hit the horizontal axis, and when you get to this last class, you have to draw a line that hits the horizontal axis to end it. So this is a frequency polygon. A relative frequency histogram has the same shape and the same horizontal scale as the corresponding frequency histogram. The only difference is your vertical scale will have relative frequencies and not frequencies. Okay, so let's go back. This is our table that we had, our expanded frequency distribution table. And this time we're going to look at these numbers here. These will be on our vertical axis. So that's what we're going to graph. We're still going to have the same class boundaries, but our relative frequencies will go along the vertical axis. So when we go from 144.5 to 190.5, that was our first class. And as you can see, we have a relative frequency of that first class to be 0.1. So we'll draw our graph up to 0.1. For the second class, we have a relative frequency of 0.07. When we draw our next graph, our next bar, it will go up to 0.07 and so on. So as you can see, it basically has the same shape as the frequency histogram except a different vertical axis. The last graph I'm going to discuss is the cumulative frequency graph, or ogive. It's a line graph that displays the cumulative frequency of each class at its upper class boundary. The upper boundaries are marked on the horizontal axis. The cumulative frequencies are marked on the vertical axis. So if you look at this graph, this is the general shape. You have your data values along the x and your cumulative frequency along the y-axis, or the horizontal axis. You're going to put your upper boundaries on the horizontal axis, actually. So what you're going to do is you're going to specify the horizontal and vertical scales. Once again, the horizontal scales consist of the upper class boundaries, and the vertical scale will consist of your cumulative frequencies. You're going to plot points that represent the upper class boundaries and their corresponding cumulative frequencies. And then you're going to connect the points in order from left to right. The graph should start at the lower boundary of the first class, and it's going to be at 0. And then you should end at the upper boundary of the last class. And when you draw your line up to that point, that should be your sample size. So if we go back to this problem, remember when we did this problem, we had a sample size of 30. So when you add up your frequencies, it should be 30. So when we end at this graph, we should end up at 30. All right, so let's look at this graph. This is the ogive. Remember I said that the graph should start at the lower boundary of the first class, and it should be at 0. The lower boundary of the first class is 154.5. So that's where we're going to start our graph, at 154.5, and it's going to be at a 0. As you can see, the rest of these numbers are the upper class boundaries. If you go back to the table, These are my upper class boundaries. That's what I'm graphing along the horizontal axis. Okay, so at 190.5, we should be at 3. 190.5, we should be at 3. Now remember, this is cumulative. So when we go to 226.5, we got to add the 2 and the 3. Therefore, we should be at 5. And we are. 226.5, we're at 5. When we go to 262.5, that's this number here, we need to add all this up. So now we should be at 10. We're adding all three of these numbers. So if you look at the graph, 262.5, we're at 10. So we keep doing this until we get to the very last class boundary. The very last class boundary is 406.5. And at this point, we would have added up all the numbers. And when we add up all the numbers, we should be at 30. So from this graph, you can see that a total of 10 adults had expenses of $262.50 or less. Okay, because this is cumulative. So remember, this was 10 here. So at this point, 10 adults had expenses of $262.50 or less at this point. Also, the greatest increase in cumulative frequency occurs between 298.5 and 334.5. So it looks like this is the greatest increase right in here. Graph kind of shoots up. Okay, that's the end of this video.